Mainframe screen applications have always been one of the hardest parts of modernization. They contain critical business logic, but they weren't designed for APIs, cloud architectures, or modern digital experiences. In this session, we'll show you how to turn this, a traditional mainframe screen application, into this, a modern API-driven application ready for today's digital architecture. So, we have a simple mainframe screen application. On one screen, it retrieves a list of users. On another screen, it lets us add a new user by entering 5 fields: first name, last name, user ID, password, and user type. We'll ask the AppIQ AI assistant to generate the same model for us, although this can also be done manually. Now that we have the model, we can start creating our app. Let's call it Users. An application is made up of several processes, each responsible for a specific task. Using the user model, we'll create a single process to retrieve the list of users and to create a new user. In other words, we want the application to display a list of users and provide an add user functionality. So after selecting the user model, we'll select the list and create operations from the list of available operations. Once we're happy with the process, we can head over to the UI tab to preview the interface and tweak it if needed. Or we can test it using mock data, just to get a glimpse of how the deployed app will look and feel, explore the functionality, and even review debug information if necessary. At this point, the application is just a shell. It still requires a real API behind the scenes to perform actions against the back-end system. So now, we'll head over to OpenLegacy's OL code. We'll locate the screen application source file, analyze it, and transform it into a mainframe RPC program, one that can later be easily invoked from OL Hub. This resource includes a reference to the screen map, which further confirms that this is indeed the correct resource. When we click the RPC conversion button, the system first verifies that all required reference files, such as copybooks and screen maps, are available before proceeding with the conversion. The conversion process takes just a few seconds. Once it's complete, we get a new RPC COBOL program that performs the same logic as the original screen application, including input validation and database insert operations. We can then save the new program to the mainframe and compile it. Finally, we test the new program by creating a corresponding module and asset in OpenLegacy Hub and executing it with test data. Beyond testing, this asset will also come in handy in just a moment. Let's head over to Skull and check the Users table to confirm that the user we created was successfully inserted. We'll execute a select query on the Users table to verify the data. Then, we'll click the Create CRUD button to generate a database module in the hub, automatically populated with assets that perform CRUD operations, such as update, delete, list, and more on our selected table. We'll use the List Users asset to fetch the user list for our application. With our Create User and List Users assets ready, it's time to expose them through a custom API. Instead of creating a generic hub project, we'll let the application define the contract. We'll publish the AppIQ users methods to the hub and generate a hub project based on that contract, aligning the backend perfectly with the app's needs. All that's left to do on the hub side is open the new project, publish the methods so the hub can expose them externally, and associate the project with the previously created DB2 and mainframe RPC modules, allowing us to use their assets. Next, we'll navigate into each method and add an asset invocation step to connect the API methods to the appropriate backend assets. Then, we'll map each method's input to the invocation step's input, and map the invocation step's output back to the method's output. We'll start with the List Users method. Add an invoke step, select the List Users asset from the DB2 module, then map the method's index and page size inputs to the corresponding asset inputs. Finally, map the returned users list from the asset output to the method's output. Now, let's test it. Looks good. Moving on to the Create User method. Add an invoke step. Select the Create User asset from the Mainframe RPC module. Map the user information to the asset input. Map the returned message code to the method output. And test. Looks good. Now that our API is ready, we can head back to AppIQ and configure the application to use it instead of mock data. Since we originally created the Hub project from AppIQ, the Hub project methods are already associated with this application, so we can go ahead and test it right away. If everything works as expected, we simply click the Use in App button to switch the method from mock data to the live API. From this point on, the method will use the real API instead of mock data. That's it! We have successfully replaced a mainframe screen application with a modern application running an API that executes mainframe RPC call and a database query. And that's how you modernize legacy systems with OpenLegacy. Quickly, seamlessly, and without disrupting your core business. Legacy unlocked. Innovation delivered.